is our fourth live session of DevOps Zero to Hero, and this is May 31st on 2020. So in the last session, we studied how to deploy a multi-pod deployment in Docker Compose and Kubernetes. Today we will continue our DevOps course, and we will focus more on continuous integration and continuous deployment and continuous delivery. Sorry. And we will study like the different aspects, why we should learn CI/CD, what is CI/CD, how to set up a CI/CD pipeline, and we will take a quick look on GitHub and how to use it, and as well we will take a look on how to write unit tests for our application. I will do like as an application, we will use our previous use case, that is the shopping cart example, to write the unit tests and do all the CI/CD stuff. So first, let me ask you: do you have any questions regarding the last week? That is the multi-pod deployment in Kubernetes. Check the chat. All right. So if there are no questions, let's start. So during this DevOps course, we saw how to write code using Golang. Then we did some REST interfaces, and we did some Swagger. Then we had our first application that is ready to be deployed. We learned how to build a Docker container because Docker has some advantages in the deployment. And after that, we said that it doesn't make sense to have only one component in a microservice architecture, but it makes more sense to have many components, and we should like divide the different functionalities of our application into different containers. This will allow us to independently write the code and release the software in different granularities and in different phases based on the stability of the code and how active is the team that is working on this particular code. So we will end up with different containers. And we saw that Kubernetes is one of the best tools to deploy these kind of applications. This will allow us to have different containers, and Kubernetes will make the connectivity and will take care of the storage and the scheduling for our application, and also some aspects of the self-healing of our containers. So if any container will fail, Kubernetes will try to restart it. So today we will focus more on the overall picture of the life cycle of our application. So when you write your code, you first start by writing some like human readable code, and you write some tests to test if the code is satisfying your requirements or not. There are some other methodologies where you start by writing the test, which will be like the specification of what you need, and then you start writing the code to respect this specification. So, and this is called test-driven development. So you write the test first, then you write the needed code to make this test pass. Once you are done, then you will go and do a Docker build in order to build your container. After that, you will do Docker Push in order to share your container with anybody that will need to use your application. And finally, you will need to do a deploy or a Kubernetes deploy in order to deploy your code. So you will do a kubectl create and give it some descriptor to create your deployment, and finally you will have your application up and running in the Kubernetes environment. So there are some tools and techniques that allow to kind of automate all this process. So all what you need to do is just write your code, and this is what all of us want to do. Like if you are developing a code, you would prefer to just I need to focus on my code. I just write my code and then I push it to GitHub, and then I want to see all this process automated. And this is the role of the CI/CD. So CI/CD stands for continuous integration and continuous delivery. Okay, so let me share my screen here. Okay, do you guys see my screen? Just
yes.
Yeah. All right.
Yes.
Okay, perfect. So CI/CD is for continuous integration and continuous delivery. So if you have software to manage, to create and manage, the CI/CD will help you to automate the different steps that I was describing, from the build process to the test to the deployment. And so this will help you like really focus on your code, and also it will kind of make you avoid any errors that you can do, because in this process, like running the tests, building the Docker image, deploying, all of that is error prone. So you can have an error in the middle at any given time. But if you automate that, you will focus one time in setting up your pipeline. But after that, you don't really need to worry about that. The system, the CI/CD system, will not make any issues or any errors if you set it up in the right way. So CI is continuous integration. So basically, it is one of the best practices that allows you to, after writing your code, it will try to integrate it with what exists, and it will also run a series of tests to validate that your code is good. So the objective of having the CI process is to find any issues really early in the development cycle. Because if you detect an issue while writing the code and writing the tests, then the cost of correcting that issue is very low, because you are still, and nobody is using that code, nobody is counting on it, nobody depends on that code, basically. So it is really really low cost to make the change there. So after that, we have the continuous delivery. So after you integrate your code and build it, then you think of the continuous delivery, which is whenever you have a new code, you want to deploy it as soon as possible and have people use it. Because generally, when you are deploying new code, it is either you are fixing some issues, which you want it also to go really fast to the users to avoid hitting a bug or something, or you are adding a new feature, and also you want the users to start using this feature and benefit from it. So the different stages of CI/CD, generally it can go really long, but you can resume it in these four steps, and there are different variations of these steps. So first is the source code, where you specify where your code is coming from. Generally, probably, I guess you are familiar with GitHub. So the source step is basically setting up your CI/CD to monitor a Git repository. So whenever a change happens to that Git repository repo, it will trigger your pipeline. Then there is the build. So if you are writing some code, you need to build it. Before running it, you need to have a first build in order to be to execute your code. And the build process has some part of validation of your code, because if your code is wrong from the beginning, then it will not build correctly. So this will kind of validate that you don't have any code issues, you don't have errors in writing your code itself. But sometimes you can have some semantic problems, but during build you don't have real kind of errors for the compiler, but you have some semantic errors that can be detected by the next stage. So yeah, so if you have an issue in the build, then the code will not run anywhere and it will fail all over the place. So it is very kind of very low cost to detect that and correct it before going to the rest of the pipeline or the different stages of your platform, of your pipeline. So once this step is validated, so you have a code that you can build correctly, no issues with the code itself, then you need to make sure that this code is doing what it is intended to be done. like if you want to implement a hello world, you want it to echo or to print a hello world. You don't want it to do something else. If you want to do some function, you need to make sure that it is returning the right values and accepting the right types as well. So, and this is where the test stage comes in handy, because you can automate that and run your own tests, and you will validate that the behavior of the application is correct based on your specifications. And also, this will prevent future developers from violating the specifications that you have. So if you add any new code, and after like 6 months you want to add a new feature, then this feature will violate your previous specification and test. Then you will detect that even without like reading all the code again and again, because the test will cover your use cases. So you will somehow detect if there is any issue in the behavior of your code. And yeah, and correcting an issue during the test is still low cost. So you need to do that as soon as you detect it. All right. And finally, there is, after testing your code, so now you have a code that builds and that passes the test, then you are ready to deploy it. Now you need a way to deliver this code and run it in your environments. You can have different stages for environment. People can have like an environment for testing, an environment for staging, and an environment for production, which is the last step. So staging and production generally should be very close to each other, because staging is kind of a clone of production. It should look exactly like production. So any execution in staging should validate that the code is working correctly. Nothing bad can happen, because after that stage, you will be hitting your users. So if anything bad goes from staging to production, then your users will face these issues. So yeah, so there are some teams, there are some big companies that they were doing CI/CD since a long time, and they have some of the best practices. Then they can even do automatic deployment in production, which like small companies or the companies that they don't have a long history with CI/CD, they will do everything automatic up to the production environment. They will not do that before a manual intervention. So you will need to run everything in your pipeline. But when you come to production, you will wait until a user or even two or more validate that this deployment should go to production. Now it is ready. There are no issues. So now we hit a button and it will deploy to production. Yeah, but companies like Facebook and Netflix and Google, I guess, are doing automatic deployments every day. So for Facebook, they have like many deployments per day. We don't really notice that because they are using some techniques to hide these features from the user, so you don't really see that. But when the time is ready, they start giving a few kind of they start to route the traffic a little bit for that to test it, which is called a Canary deployment. So they will take 5% of the users and then show this feature to them. After that, if this succeeds, they will proceed to add 10%, 20% until hitting 100%. If it fails, then they will just go back. They will roll back, and nobody, like the harm will be limited to this small percentage where they will do the deployment for. Yeah, and as you can imagine, like a failure in this phase, like in the last phase, can be critical, because you can be deploying to production and users will start seeing an issue. And if you see that, then this is a bad experience for users, and some users might even leave your platform or just let go of your software. So this is not good to have. So it's better to invest in the CI/CD process in the beginning, in writing the code, building it, and doing lots of tests before deploying, rather than just regret the fact that a buggy code went to production. So some of the benefits of CI/CD is like, as a developer, you don't really need to worry about building a Docker container, deploying it to Kubernetes and all of that, even though it is good to know, but you don't want to pass all your time doing that. You would prefer to focus on writing your code and just seeing the behavior of the system in production and learning and enhancing your code, but the focus is on your code. Then for QA and product stakeholders, they have an easy access to the latest version, because automatically any new code will go through the different pipelines and it will be ready to be deployed to the user. So they will be easily able to use that and without any manual interventions generally. Yes, the same thing, like the product updates are really smooth, because like in the past, like if you are planning for a release for your code, there is a lot of stress, and people try to avoid doing deployments during Fridays because they have the weekend coming and they don't want to be fixing the issues on the weekend. So there is a lot of stress to avoid that. But if you have a lot of tests and you are covered by your CI/CD pipeline, then it doesn't matter when you will do your deployment, because you have enough security or safety nets to control your code before reaching your users. Then you have the logs of all the code changes, because you are maintaining the history of the changes, when they got deployed, where they came from, what changes had shipped in this version. All of that is recorded with your CI/CD. And also you can roll back easily. Like if you have a failing version that has some issues, you can revert back in any stage. So for example, if you fail the test, then you will not even proceed to the deployment, but you will go back and enhance the code before proceeding. So it's really fast feedback that you can get, and that will give you enough safety to use. Any questions about this? Let me check the chat. All right. So now, as like I will try to go through different steps of these CI/CD pipeline phases. So the first thing is the source, right? The source is generally related to a tool that will manage your source code. And here I will just open a bracket here, and I will talk a little bit about Git and GitHub. So if you are familiar with these terms, then it is worth like just repeating these kind of commands in order to understand how Git protocol works. And if you are not familiar with that, then this is a good time to ask your questions and learn what is Git and what is GitHub. Generally, people kind of confuse Git with GitHub, but they are two different things. So Git is a version control system for tracking changes. So if you want to track the changes of your code and manage, like every change that you will do should be in the history, and you will be able to go back to that version at any given time, then you can use Git in order to track the changes of your software. So it is designed for coordination between different users, because if you have a big team and you want them to collaborate on the code, everyone will be working on some code, and in the end they want to merge that code in one central place. And Git allows to do that in a very good way, and it allows also to resolve any conflict that can happen. Imagine yourself writing a hello world class, and someone else in your team is trying to modify the same hello world class. Then you are trying to push this code in the main repository. Then this is kind of a kind of conflict that you need to resolve before like breaking your repository with this conflict. So Git allows to resolve these things. All right. So yeah, so there are different solutions that offer Git as a service. So if you want to use Git, you don't need to implement it from scratch, but there are some known services. The most known one is GitHub. There is GitHub, SourceForge, Bitbucket, and there are some people using GitLab as well. But yeah, like many people confuse Git with GitHub, but GitHub is only one service provider for Git. And like Git is the system that manages that, but GitHub is the provider. Like it is a provider, like providing repositories or Git as a service. Any question between the difference between Git and GitHub? All right, so in order to use GitHub or in order to use Git, it's really easy. You need to install a Git client. There are different ways to do that, and like it depends on the system that you are using. You can install a Git client like for Windows, Linux, or Mac, and you will be able to use the Git command line. So yeah, so if you, I guess like most people have used Git in one way or another, and if you were following this course, you might already have used Git at some point. But how to create a repository in Git? So it is easy. Just create a folder and then do a Git init. So if I do this, let me. If I create this one and I go there, if I do Git init, this is fine. I have a Git repo. Now, if I do any change, let's say I have a README file. So now I have this README file. It has some content, and I have a Git repo, so I can start adding files to my revision history. So now if I do Git state, so I will see that Git started like saving data about the about my repo. All right, so it is pretty straightforward to create a Git repo, but the next steps are more important. And generally, also you can. So this is how you create a repo from scratch. But you can also clone a repo from a remote place. So you can clone repositories from your local machine to a different place in your local machine. And you can also clone from a remote repo. So if I go, for example, to this one, we said that GitHub is a provider of Git repositories. So I have this repository in my GitHub account. So I can go there and copy the address of my repo, and in any place here I can go and let's say I will just create a new repo test. I will go to repo test and do a Git clone of this shopping cart. So what happens here is that the Git client will connect this address, which is GitHub, with my ID and the name of the repo, and with the extension of the repo, generally is .git thing, and it is using a protocol called Git. So now, if I do an ls, you'll see that Git cloned or copied this repo to my environment. And if I go there, then I will see that all the documents that I'm seeing here are cloned to my environment. So this is a Git clone. So basically, it is copy everything from that repo to my local environment. Yep. So then now I have a repo and I have Git that is tracking my changes. How Git does that? So basically, I have the repo, which is my working directory, and I have an index. So the index here, it is tracking any changes that I will do. I can add them to this index. So if I do some changes, for example, let's say I will modify. So if I do a git status, this will show me if there is any change or something in flight that I need to that I change it since the last version that I have. You see that I don't have any. So if I change, let's say I will change the README file. So let's say I will change this line to say this is a simple app to learn Go programming during the DevOps class, let's say. All right, I will save that. So let's see what Git will tell me. So if I ask about the status, what is the status of this repository? So it will tell me that you modified readme.md. Now, in order to add this change to my history, I need to add it. So I need to do a git add. So a git add will take this file, the README file from my working repo, and add it to the index. So it will be in the index, which is the staging phase, like the preparation phase of my environment. So I can do a git add of README. So now if I do a git status again, so I will see it in green. So when it is in green, it means like it is already in the staging environment. So here, like in the previous value, it was showing that these are changes that are not staged for commit. They are not ready. They are not in the index to be committed. But now it is saying that I have these changes that are ready to be committed. So they are in the staging environment. So now what I can do, so now I have my README file. It is here, it is in my working dir, and it is already indexed. So I am ready to put it in my head, or to save the changes in my in my repository, and I can share that with anybody. So so here you can read the definition. The local repo has 3 trees. One is the working dir, one is the index, and one is the head. So the repo holds the file, the folder, like the working directory, holds all the files. The index contains the staging area. So this is like a temporary thing. If I want to commit anything, I need to go to add it to the index and then commit it. Finally, we have the head, which points to the last commit. So a commit is really like saving something. So you commit it. It is already in my history. So before adding it to my history, I cannot share it with anybody. It is not persistent in my repo. So now I have I did the change to README, and it is in the index. Now I can commit it. So how to commit something? So I need to do git commit and add a message. So I can do it in this short way, or I can do it in let's do two different ways. So the first way is to do git commit. This is my first awesome commit. So now it is committed. Now if I do a git status, I don't have anything in my so my tree is clean. I don't have anything staged or unstaged, but I have one commit. So it says like your branch is ahead of master. Master is the one on GitHub, and I have one commit. Let's say I will do another change. Let's say I will change README again. I can change any file at any given time, and I am not limited about the number of files that I can change. After saying, yeah, okay. Okay, DevOps Zero to hero. So now I have a new change, so I can do a git status. Okay, so I need to add that to my, I can do a git add point. So git add dot will allow me to add everything. So if I have many changes, it will add all of them to my to my staging. So now I have it staged. I can do git commit, and if I don't specify the flag, the M flag, it will open kind of an editor to that allows me to make the changes. So I can use the same message. This is my second commit. Generally, you should use some meaningful text. For example, here I would use, for example, if it was like a real project, I would say added the right name of the course or of the class. And then you can save it. Once you save it, you can say that it went. So now I have 2 commits here. In order to see the history of the repo, you can do Git Log. So if you do a Git Log, then you can see like all the changes that I have done for this project from the beginning. So these are this is the one that I did just now. So this is my second commit, and this is the one that I did before. And I can go back to any of these versions at any given time. So this is like the advantage of using Git is, or any kind of code like source control or source versioning control system, is that you will be able to go back to any given point. If you saved it, you can go back. So I can go to this commit, I can go back to this commit, or and this is one advantage. So if you have any issue, so imagine that you are writing some code and you introduce a new problem in the code or a new bug in your code, then you can easily go back to the version that you know was running without issues. So yeah, so now the code is committed to the head, and we can share it with. But yeah, so it is committed to the head, but it is still in my local machine. So if I look here and open the README. So I still have the old version. I don't have the new version. I don't have the version that has the name of the class in it. So in order to do that, in order to share that, I will be able to do a Git push. Now I can push this to my code, so to my remote repo. So if I do that, you will see that it will push it. It might take a few seconds. Then if I refresh this, it should show up the new version, which is okay, so it has the DevOps Zero to Hero class, right? Any questions so far? Okay, so I see, Lamia, you are confusing between Git and GitHub. So is the confusion gone now? All right. Okay, so we see that like Git is managing this, and in GitHub also they have a version of Git that is running, but they have an optimized version that will manage the server, and you're running like the central thing for you. You will not be managing the central repo in your machine, but GitHub will be managing that for you. All right. So now we have this this command to share. So if you have new code, you know that you need to add it, you need to commit, then you need to push in order to share it. If you want to revert back, you can revert the code, and then you don't need probably, I don't know if you will need to push or not, but it depends on the changes that you have done. So then there is, okay, so, okay, if you in your mode, okay. Yeah, so we already did that, so it's not an issue. Okay, yeah, generally also if you create a new repo in GitHub, it will give you the way to do it. Let's imagine that I want to create a new repo directly here. Let's open this tab and see. So what happened? Let's say I want to create a new repo on GitHub. I give it a name, test repo. I can give it a nice description. This is my nice repo. And I can keep it private if I don't want to share my code. And I can keep it public if I want to share it. And I can initialize it with a README, and I can add a git ignore. So git ignore is a way to say that I need to ignore these files. Don't worry about these files. So we can see that later on. And I create the repo. So once I create this repo, so it will give me the list of commands that I need to do. So if it is in your repo, then this is how I will do that. So I will just clone it locally, and actually, if it is a new one, so they say that you will just do git init in that folder, and this is similar to what we did right now in the previous example. We did a git init to have this example So here we did a git init, and then we added a README file, and then we committed it. And after that, you need to do that, like to follow these steps in order to start using your remote repository. So this will allow you to create and publish to your new repo. Okay, so what is the difference between clone and remote? So clone basically is copy this folder from this location to my local folder. While remote, basically, it is, so a repo has different remotes. What does it mean? It has different remotes. So for example, my repo, my shopping cart repo, one of the remotes that I have, let's say Git, not this one. Let me go to repo test and shopping cart. So if you see here, I have one remote called origin, which is this one. So this is the origin of my folder. And how it is known? It is known with the address of my repo. And this allows me to do fetch from origin, like get me all the changes from origin. And also when I try to push, so you remember when I did a push here, I did a push to origin for my origin to master, to the branches called master. We will talk about the branches in a few minutes. So when I did that, it did a push. So it picked this one, and it did a push to origin, which is this address. So these kind of remotes are addresses that my repo can talk to. So I can have many, like for example, I can do, let's say, I want to push the same content here. I don't want to have different like remotes with the same name. For example, I want to do git add second remote. Let's call it second remote, right? So now I have, if I do this, you will see that I can do a fetch from this one, and I can push the same content. I can push it to my origin or my second remote. So if I repeat, so let's imagine that I have this content of the repo, and I want to push it to another place, which is my test environment. So I can do this Git push, and I will push to my second remote. And which branch? I will push it to master branch. So now you can see that what I did, I took the content and I push it to this remote. So I can choose the remote. So remote is basically a name of the URL that I'm using to push and pull. But clone is the action of copying the content from the remote place to my local folder. So now if I go back to this one, I will see that I have the same content being pushed here. So now I have two remotes. So I have two targets where to push or to pull from. So this is okay. So this is like you cannot compare like clone and remote. Clone is the action of copying, and remote is like an address that you will be able to push and pull from. Does this answer your question, Ahmed? All right, so I will suppose, okay, great. Okay, I will move on because it is getting tight in time. Okay, so next thing to use in GitHub and Git is the branches. So what is a branch? Basically, people, when they start deploying or writing some code, they start with a master branch that contains everything. And if they want to add a new feature or a new functionality, they open a branch and write their code in this branch, test it in that branch, and once they are done, they will push it back or merge it to the master. Imagine you are writing, let's say, a calculator, or let's talk about our shopping cart example. So you are writing the shopping cart functionalities. You added the like a user should be able to instantiate an empty cart, and he can be able to add and remove products. You are done with these features, they are in master. And after that, you want to add a new feature that will allow to get the content of the cart, which is the third feature of our cart. So what you will do, you will not modify directly in the master branch, but you will do your changes in a feature branch. So let's imagine this scenario. So I want to add a new functionality. Let's say I want to enhance my README. Okay, so this will not require lots of changes, but it is a feature. Like I'm adding new things that require testing, reviewing, and probably more revisions before being added to the repo. So what I will do is I will create a branch. So to create a branch, you need to do git branch -b and give it the name. I think, let's see, I think it's yeah. So I think I have an error here that I need to fix, because it is a git checkout. So you do git checkout and you do -b and you give it the name of the branch that you want to use. Let's say README enhancement. So this is some work that I need to do. So I will go to the README and make my changes. Okay, I have my README. It contains the latest changes from master. Now I need to make some changes after setting up your environment. It is time to implement your methods. Now you need to use checkout -b for creating a new branch. This is some just dummy text that I'm trying to add here. So now I did some changes to my code, and let's say, so I have this change. I need to add it. Sorry, git add, and I can do a git commit. Added. And let's say corrected usage of how to create a branch. All right. So now I have a new change, and I am in this scenario. So I have the master branch, and I created a feature branch that has some difference from the master branch, because this change is still in my local machine, and I want to push it to the remote machine, and also I want to merge it with master at some point, right? So what I will do is, so I need to, in order to push it first, I need to do a git push. So if I do git push right away, it will tell me, okay, you need to set up this remote branch in GitHub. So I can do this, copy paste this, and it will add the code. All right. So now I pushed that code to the shopping cart. So it is here. And if you open GitHub, you will see that there is a new branch that was created. So now I am in this scenario. I have two branches. So the content on this branch. So let's look. So here I don't have the last line that I added, but if I go here, README enhancement, which is the new branch that I added, you will see that I have these changes, right? So now what I can do, let's see. So so now I am in this point. I need to do this this merge part. Okay, so here there is description on how to move from one branch from one branch to another. So we did the git push, and I can, for example, I can do a git checkout master. This will take me back to my old branch, which is the main one. And if I do a cat on my README, I will see that I don't have the changes that I did before, right? So because I didn't merge them to master yet. So I will go back to my master branch, and let's say, so if I want to go back to any other branch, I can do that with the git checkout. So if I do a git pull now, it will not show any changes because I didn't do any merge. So the master branch is still up to date with GitHub. Okay. So what I can do now, so either I can do that from here, so I can merge in my local system, or there is an easy way that you can do from GitHub side. So there is this feature of compare and pull request. So you can create a pull request. So what a pull request is basically asking to merge the new content from your feature branch to master. So any change that you did in your feature branch, it will go to master. Yeah. So if you have any question regarding that, just post that to the chat, and I will try to answer that. So here I can do added README changes to use git checkout -b for creating a new branch. So this will explain what change I have done, and I can create a pull request. So if I am doing this work as part of a team, someone else from my team need to go and review this change. For example, like we have like 5 people working, so someone will go and take a look at the code, make some revisions, and recommend some changes. For example, here he will be able to directly see the changes. So here I have I added a dot in the end, so he can say that this is right change. And here I have this line. So now after he can give me some review, or he can approve it. Like he can say this looks good to me, for example, and he can approve. Yeah, so here it is preventing me from approving because I am the author of the pull request. But if I have someone else in the team who can go there, he can approve my my pull request. But since it is my own folder and my own repo, I can just go ahead. I know that the change was right. I can do a merge. So now I can do a merge. So what happens now? So is that these two features, these two branches, they have the same content. So now the master has the changes. So if I go here and I go to the master branch, it should show up the changes that I have done there. You see here. So the changes happen there. And if I do a git pull again, I need to see the changes. So you see that the README changes. And if I do a tail on README, you will see that I have the changes being shared in my repo. So this is how I do git merge. Okay, yeah. So if I at any given point, if I make some changes and then I decide to just revert them back, I can do a git checkout on this name of the file or the name of the folder, and I will get the latest. It depends. Yeah. So if you want to make a merge to using the CLI, you need to decide which branch should be merged to which one. Because if you let's say I did the change to master. And I want to merge it to my feature, or the same thing. If I did a change to my feature and I want to merge it to my master, so I need to be on the target branch. So I need to be in the branch where I want the content to come from another branch to my own branch. So here, for example, the example here, I am on master. I checked out master, so I am on the master branch, and I wanted to do the same thing that I did using the GitHub here. So I wanted to bring the changes from my feature to master. Then I need to so I am on master, and I did git merge this branch. So take the content from this branch and try to merge it in my master. All right. So yeah, so Git will try to do the merge, but sometimes you can have conflicts. When conflicts happen is when two people are doing changes to the same file in the same branch at the same time. So if I am working on the same branch and someone else go and modify README, for example, at the same time, then I will have a conflict because we are trying to change the same thing at the same time, and then GitHub will tell us, okay, guys, you are changing the same content in two different ways, so let's try to resolve that. So there are different tools to resolve these conflicts. Sometimes it can get really complicated, but to avoid it, you need to synchronize between teams. But if this happens, you need to make the changes to correct the conflict, and then say that this conflict is solved, and Git will do the needed after that. And there are some tools to resolve conflicts in a visual way, where you will see the difference between the different versions and pick up the right change to apply. Okay, so yeah, so one useful thing to have is the Git reset. So for example, if I let's say I have these changes, and I want to go back to this version before this class completely. So I can do Git reset, let's say. Okay, I can do Git reset and go to this version. So now if I open my file, it should be in the same version that we started. Right. Yeah. So I can check out these changes. So like the last change, if I do a Git log now, it doesn't have the new commits that I did. So the last one was on May 6th, which is not today, definitely. But I can, so I have this, and I can check out this one. So if I want to get back to the previous version, I can do git checkout. And now I am completely in the previous version. I don't have any changes, but it is saying that master is ahead of me. So I am late by 4 commits, which are the commits that I did today. So these are the 4 commits that I did here. So you can see the commits in the GitHub. So I have 4 commits today, and these are missing from my local machine because I did the changes and then I reset in my machine here. So I don't have any changes that I did today. So what I can do, let's imagine that I introduced an error today and I want to go back to this version, and I want to apply it also to this GitHub repo. I can do a Git Push, and I can do, I think it's force. Okay, so now I forced my my master to go back to that version. So if I revisit this page, I will see that I lost all these 4 commits, and my shopping cart is in the previous version. So the last change that happened 25 days ago. So this is like how to force. Yeah, this is not a recommended thing to do, but in some major situations, you need to force it to kind of clean up any mess that you have done. So this is like the introduction to GitHub. So do you have any questions regarding that? Git and GitHub, I mean. All right, so let's move on now to the CI/CD pipeline. So now, like we covered the first part, which is the source part or the code part. So now we have our code. We are sharing this code using Git and GitHub. Now we want to be able to set up a pipeline to do our CI/CD work. So So we need to pick up a tool. There are many tools for CI/CD. Some of them, like many people are familiar with Jenkins. Other people are using Concourse. There are many in the marketplace. So you can pick up any CI/CD tool. They are very close to each other. There is Circle CI. But for this course, I will be using Concourse because I like this tool, and it is an open source tool, and anybody can use it for free. You can set it up and start using it. Like many people are using Concourse, and they can also extend Concourse. They can implement their own way of doing things. If you don't find the right plugin or the right extension for Concourse, you can implement your own, and this allows you to set up a pipeline and manage it in a good way. So an easy way to test Concourse is to use Docker Compose. So what you can do, if you have Docker and Docker Compose set up in your machine, you need just to get this file and then do Docker Compose app. like during my preparation, I downloaded this, so I will not do that part. So I already have it in my system. So if I do, all right, the concourse. All right, so yeah, so this is where I have my pipeline work. So this is a Docker. This is the Docker Compose that you will be deploying. So it has basically two images, one Postgres and one Concourse image, and it has some configurations, and one of them is the user and password. So here it is using test as user and password, and it will be using localhost. So this is a test environment, not a production environment. So please use it as such. So after downloading that, you can do Docker Compose app. And yeah, so now we should be able to go to localhost and see that, see what's going on there. So the first thing that you will see is that you can do a login. And since we set up the pipeline to use test, then you can use that as your thing. All right, so I already have that. Let me fly. Okay, so I will destroy this pipeline because I want to create it with you. I created it previously with. Okay. Okay, so I need to go here to log in. Yes. Okay. So now I don't have any pipeline, so we can start from scratch. But this is like the main view of the pipeline. So you will get yourself in this account. Welcome to Concourse, no pipelines. And here on the right bottom side, you can download the executable for your platform. For example, for me, it is Mac OS, so I need to download this one. For Windows, you can download this one, and for Linux, you can download the last one. So after downloading it, you need to put it to add it to your path in order to be able to execute it. And after that, you can start using the pipeline. So let's say I will do a login here. So for my account, I can do so starting to use the CLI. First thing we need to tell it, like, you need to use this pipeline or this Concourse instance. And you can log in using this user and password. So this is the first thing that you need to do. And then we are ready. So it will tell you that it logged in and it saved this target. So now we will be able to use this pipeline to create our own stuff and deploy it. Okay. Did anybody try to set up Concourse? Did it work? Any issues? Okay, so now after the first setup, which is, I guess it is pretty straightforward. You do the Docker Compose app, then you do the login, and you are ready to go. So we can basically look at our we can create our own pipeline, and here I am using this file just to get started. So what this file is saying, this is the first configuration of my pipeline. So basically, a pipeline in Concourse is using resources and jobs. So you define some resources that you will be either consuming or producing, and then some jobs to say this is what to do. Like get this GitHub repo, for example, and run these commands or run these, execute these files. Do a Docker build on this GitHub and produce this Docker image. Take this thing and deploy it to Kubernetes. These are like kind of tasks and jobs that we can define. So in this example specifically, so we have one resource. And so you will get familiar with that very quick because it is not very complicated. You have two parts. Like the worst case, you can have three parts, which are defining resource types if you want to create a new resource or bring a new resource, then resources to define your resources, and jobs to say what to execute and what to do. So here we have one resource called shopping cart, and its type is a Git. So it is basically saying that this is a GitHub repo, so it will get the code from here. This is the Git repo. We are specifying the URL, and we are using the master branch. And in order to use Git, you need to specify. You need either to use HTTPS and specify the user and password, or use Git protocol and specify an SSH key. So here I'm putting my private repo key. So I'll show you how to set this up in a minute. Then I have only one job for this pipeline. This job is basically to run the unit tests for my shopping cart. So I have some tests set up in my repository. So I will start by getting the shopping cart. What is the shopping cart here? It is what is defined in my resources. So any get or anything that is defined here to be get, it needs to be defined in the resources. So getting a shopping cart basically is getting this resource. And here I'm saying that this is a trigger. So any change that happens to this resource, it will trigger this unit test to be executed. And what is the task in this? And this job is to run unit tests. So and this is using this file. So generally, I need to specify what needs to be done in my task. So if I go to shopping cart, which is my resource, my GitHub resource, I need to find a folder called CI, and I need to find this file that will describe what I will do exactly. So if I jump here, I go to CI, I will find unit test.yaml, and it is basically, if you see, it is describing a Go Docker image. And it is taking the repository itself, and then it is running like /ci/test, which is a binary. So basically, it takes the repo and tries to build it inside a Docker image by executing this test. And this test is basically what it is doing. It is downloading the dependencies of Go, then running this command to run the tests. So this is basically what you will do manually in order to run the tests. So let me jump like for a minute or two to show you the tests that I wrote for this example, and then I will jump back to the CI/CD. But this is going to give you a small idea about writing tests. So this is my shopping cart, and let's open the cart file. So in the cart file, I have the cart.go. If you guys remember, we wrote that together in the past. So it has some code. For example, this is how to add an item. And I have also a test file for that, which is called cart_test.go. So basically, what I will be doing, like for each new feature I will write, I need to make sure that it is respecting my requirements or the behavior that I expect from my code. For example, if I call create a new cart, which is a call to the new cart method here in line 23, I expect that the cart will be initially will have 0 cost. So if I create a new instance of the cart, it should be empty. It should be 0. And if I call it, I expect that there are no errors to happen. Same thing for add item, let's say. So for add item, I have some expectations from after adding an item. And for example, if I call add item, I expect that there is no error to happen, which is specified here. And there are no, and if I so if the item is empty, I should not be able to add it because there is no meaning of adding an empty item. So I have like the different tests of my code. So if I try to add a partially empty item, So it should fail to add the item without ID. So if I don't have the ID of my item, then it doesn't make any sense for me to add it. So this is what is covered by this this context. So you don't really need to understand every aspect of that, but this is basically these are unit tests for my code. So every step in my code should be tested. So if you look at the steps here and the verifications and checks that I'm doing in the code, you will find a test for these verification. So every time I am thinking while writing the code, what should I do if I get an empty item to add? What should I do if I get an item without ID? What should I do if the item is without any quantity or without a price? What should I do? And then I will try to write the code to cover all these edge scenarios. And this is how I come up with my code. And like I start writing the tests, then I start answering these tests in the code in order to make it optimal and in order to make it respond to these questions. So after that, after writing the tests, which is, I think like these few minutes will not cover writing the tests themselves, but generally, like this is like I wanted to give you the mindset of writing the tests. It was supposed to have a whole session about it, but I don't think that we will do that in this course. So yeah, so after writing the test, I need to run them. So every time, in order to run the test in Go, I do this. There is a platform called Ginkgo, or a framework called Ginkgo. So I do Ginkgo run my tests in parallel in the different folders, and it will go through the different tests and check if they are executed or in a correct way, or if they fail. So if they fail, then this makes me think of changing the behavior of my code, because I'm not respecting what is expected. I'm not giving the right answers to the questions that I was asking while writing the test. So now the tests are passing. I have 12 tests that are passing, which means like I am covering some part of my expectations in a correct way. I don't have any failure and I don't have any pending tests. So I'm good to move forward. So now I will close this this parenthesis and go back to the to writing my CI/CD. So now I have the tests and I want to run them as part of my CI/CD. Any change that I need to do, I need to execute my CI/CD to make sure that that my pipeline will take care of that. So all right, so this is what's happening in there is getting the dependencies and doing this Ginkgo -r, which is running the test. Take the code, put it in the Docker, run the test, and see if it will respect my requirements or not. And this is exactly what it is. Yeah, so now I was specifying some keys here. So this is the private repo key, and I like in my let's say. So in my keys here, oh, I need to go back to the. Okay, so now I'm back to a concourse. So cat keys. So here I have a bunch of private things. So one of them is the private key that I will be using, which is an SSH key. If you are familiar with SSH, it is your private key, not the public key. It is the private key. So it should not be shared in GitHub. Publicly, you can share it in a private repo or just keep it local, because it contains a very important secure key that identifies your laptop or your machine. So you should not be sharing that with anybody. So this is why you can keep it defined in a private file. So here, this is how you put it. You will do a cat, or you can like take the content of your private key and place it in this keys.yaml, and this will allow you to connect to GitHub in order to bring the repo content. So once we have that done, we can apply this pipeline. So we will take this pipeline and load the variables from this keys.yaml and send it to our pipeline. All right, so when you do that, it will ask you, do you want to apply these changes? Like, does this change look familiar to you? Is everything correct? Does everything look right? If everything looks right, then you hit yes, and now it will tell you that your pipeline is posed. And to impose it, you can run. You can go there to this address, and you will see it. You will see your pipeline. So you see that I have the pipeline and it is posed, so I can impose it. So to start running. So it might take a few seconds to kick off the pipeline build, and it will run the unit test for my shopping cart, which will mimic what I did here when I did the Ginkgo run, but it will do it for me. So I don't need to do that in the future. All right, you see that, okay, the pipeline started now, and you can go ahead and look what's going on. So now it is doing a get. So if you remember in my code here, the first thing is to get the repo. And this is what's happening here. So it is getting the repo. So now it did get the repo. It did a clone, which is just exactly git clone that we did before. And now it is running the unit tests. So if you say it is building a Docker image, and it will execute the commands that we have here. So it will do these commands in order to run the tests. So you will see that this is what's going to happen. So now at any given time, if we push any change to the repo, this pipeline will pick it up and run the unit test for us. So we don't really need to do that manually every time. So this will happen automatically for us. Do you have any questions in the meantime? So the private key basically is so if you use it, so if you ever use SSH, you will find your keys in your private folder with this address, like my private folder /.ssh. You will find two keys basically, one called ID RSA and one called ID RSA pub. If you don't have that, you can do an SSH key gem. I think that's key gem. So this will allow you to generate a private key and a public key. So I will not do that because I already have one. But this will ask you to create a public and a private key and save it in that location. So this is my users, my ID.ssh/ID RSA, and it will also create the ID RSA.pub. And you need to, most probably you need to provide this into your GitHub. So if you go to your GitHub environment, you can go to your profile and specify, give me a second. Yeah, if you go to the settings, you can add your SSH key. Here you need to add the public key. So you copy the content of the ID RSA public. This will allow GitHub to know you. So this is an identifier for you. So you can put that here and give it a name, and then you will start. You will be able to use SSH or Git protocol in order to clone things. Yeah, so this is very important to be able to use your public key or private key in order to get stuff from that. So yeah, so you see here that the pipeline succeeded, and it did almost like the same things that I did before. It shows that I have 12 tests passing and 0 failing, and if everything went right, it will become green. So now we have a green pipeline, which is like the happy path, our environment. All right, now this covers like the CI part. So this is continuous integration. So you get the code, you run all the tests. You can have many stages like that. You can run units, you can run integrations, you can run smoke tests, any kind of test, you can run it. It will be in the similar way that we did it here. All right, so now the next step is, how about the continuous deployment? So we did the CI, now let's do the CD. Okay, so this, yeah, as you point, okay, so we covered this part. Now we only have the CI pipeline, and we want to do the CD part as well. So let's go further. So I have, so in order to do the CD, we have we have to think of the different steps that we that we talked about. So we have first what we are doing in the life cycle of our software. So we create the code, we push it to GitHub, then we run the tests and see if it succeeds or fails. If it succeeds, then we move on and try to build a Docker image out of it. So once we create the Docker image, we deploy it to our Kubernetes environment. So we will try to do that in an automated way. So in the previous live sessions, we did that manually. Like we did every step of these things manually. Now we want to automate that, which is the advantage of the CI/CD. So yeah, so I will start from this file. And I will give you an explanation. So I told you that Concourse considers three things generally. It is a resource type, then it is basically using resources and jobs. So if you don't need to define a new resource type, then you will use the standard resources. So you will not need this first part. So you will deal basically with defining resources and then describing what to do with these resources. But in our case, since we will be doing a deployment on Kubernetes, then we need a new definition. We need a new resource that will allow us to deploy anything to Kubernetes. Since this is not a part of the main CI/CD world or the main Concourse world, it was implemented by someone else, and this is a type called Kubernetes, where we will be able to do Kubernetes deployments from the pipeline itself. So this is only the definition of the type, and we will be using resources from this type. So let's go back here. So our resources, we still have the same resource, which is the shopping cart, which is our Docker, our GitHub repo. Then we want to run our tests on that. Then if the tests succeed, we need to build a Docker image and push it to Docker Hub, which is covered by this resource. So we have a Docker image resource. So whatever the output of our build, it will be a Docker image. So we need to define this as a resource. So here we are defining the type Docker image, and the resource, it will, like whatever will be pushed or pulled, it will go to my Docker Hub environment. And it will use my username. You can change that to use your username if you wanna use yours, and you need your Docker password. And the Docker password you will get when you create your Docker Hub environment. And you can put any tag here. For example, here I'm just specifying the dev tag, but you can specify any other tag. Afterwards, we have a third step or a third resource, which is the Kubernetes deployer. So the resource that is responsible of deploying our stuff to Kubernetes. So now we cover all the different aspects out of it. So for this resource to work, we need to define the server address, which is the address of our Kube API server, and we need a token that will allow us to manage the resources in Kubernetes, and also we need the certificate authority that will allow us to authenticate with the Kube API and be able to send queries and execute, create deployments in doing this kind of things. So these are like the definition of the resources. Now we need to define how to do these things. So the first part is, first let's run the unit test for our shopping cart, which is the similar as we did before. This will execute this file. Then we need to build the Docker image. So how to do that? We have to get the shopping cart, which is the GitHub repo. And here we are adding, sorry. We are adding a constraint to running this shopping cart. So we don't want to build the image if the test fails. So we want it only if it passes the previous stage, which is run units for shopping cart, which is this job. So if this job fails, we don't need to run this one. But if it succeeds, then we need to automatically run this one and to do this thing. So basically, we will get the shopping cart and execute, do a build. and put the result of this build in our Docker resource, which is the shopping cart image that we defined here. So this is the resource that we defined. So we will put there the result, whatever result that we have, we will put it in our Docker Hub. So the third step, which is the deployment part. So we will deploy to Kubernetes. What we will deploy is we will get the repo, and if it passed the shopping cart image, so if we succeed the build of the Docker image, then we want to proceed and deploy to Kubernetes. Otherwise, we don't really want to do that, because if the build fails, there is no reason to do a deployment, which is one of the steps that we talked about previously, where we need to make sure that everything goes right before doing the deployment. Because otherwise we will be introducing some bad behavior to our environment. So we need to make sure that it passed the unit tests here, and it passed the build here. After that, we will be doing some Kubernetes commands, which is basically we will apply the deployment that we have. So if I go to my repo, so if I go to the repo here and I go to deployment, I will find that I have some configurations here. So I have, I don't really need this this file. So I will apply any change that happened to this environment. But basically, the service will not change, but the deployment will change. So it will just reapply that and create my my deployment basically. And yeah, so and it will wait until this this application is ready. Yes, so we have some predefined resources. So the best place to go is Concourse CI. Yes, so here you will find all the documentation and examples and the resource types. They have like different resource types that you can add. There are some that are already predefined, and there are many others that you can reuse from scratch, like the Docker one, like Git, like the version. There are many resources that you can reuse. Yeah. So and even if you don't find a resource, you can define your own. You can copy one existing one and modify it and use it as your own resource. So yes, so basically, how did I attach that to my environment? I still did not do the final stuff, but like there is this this Docker image, which is defined as a resource type, that contain a kubectl command line. So it has kubectl installed there. But in order to make it run, I need to give it some information, which are the address of my server and the authorization part. So in order to have the address, I defined this resource as Kubernetes production. So I give the kubectl that is installed in that Docker image. I gave it the address of the server. So I tell it, if you want to use a server, so this is the server that you need to talk to. And if you want to use do anything, you will not be authorized until you use this token. So this token has some privilege to do things. It is basically a secret that contains some authorization or permissions to do things. So if you are a user and using this token, then it is giving you some permissions. It is close to what we discussed earlier today about the role binding and the authorization, but this is using a token to do the authorization. And also, it is using certificate authority in order to validate that that this user is authorized and authenticated in the correct way. And I will be adding this these variables as well. Yeah. So basically, if you want to add a new thing that is not covered by the main resource types, you need to define that resource type. And here I define this resource type, and it is coming from this environment. and I'm making like I'm saying that this is of type Kubernetes, but this is not a predefined type. So it is the name of this thing that I defined here. So this is how I brought this this type, and this is how I configure it to use my own version. So I will go ahead and apply that. But before doing that, I need to have a running Kubernetes environment. So so here I will need to run, let's say, I would run Minikube. So I will run Minikube in order to make the deployment, and then I will be replacing these values with the right values from my environment. So, because every environment has its own token and its own authority. So I need to make that. I need to implement that and change these things accordingly. Does this answer your question, Ahmed? All right. Okay, so we will give it a few seconds to get started, and yeah, it should not take that long to start. All right, now we have our Kubernetes environment ready. So let's check. We don't have anything running in this namespace. And what we can, so we need to configure this Kubernetes environment with our CLI or with our pipeline. So the first thing is to add these variables. So the first thing, I already have the private repo key, but I need to have, and also I put my Docker password in there, and I will not share that with you. I need now to add the server address, the token, and the CA. So how to find these values? So first thing, if I do a kubectl config view, this will give me the CA thing. It will give me enough data to cover. So this is the certificate authority file. So if I do this. So if I do cat this, so this is what I need to put in my keys file. So if I do, I need to change the keys file. So this is my my certificate file. I need to put just make sure that that you have the right indentation here, because otherwise it will kind of refuse to use it. Adding the right spacing. So now I have my my CA, and now I want to add also my my token. I need to add the right token for that. So if I do, so now I covered the first part. So here I have this CA. Now I need to modify this, which is also shown here. So this is my IP, and the server for my IP. So it is 80. So I can also modify my my pipeline. So this is the same content that you were seeing. So it is just 18 here. The last part now is the token. So if I want to know the token, so I can get the default token from the kube system by using this this command. So basically, I will get the secrets from the kube system that has a default. So I will see that I have a default token. I can use this this token in my environment in order to be able to do deployments and create things using my pipeline. So in order to see the content of that secret, I can do a describe on this secret. So, okay, so it doesn't see it because I need to use the kube system namespace. All right. So now, yeah, now I see the content of this secret that contains a token that I can use. So if I copy that token and add it to my keys, so it should be like this this last line. Great. Okay. So now I can paste my new token, and I should be ready now to apply my changes. So what is the change that I will apply? All right. So now I have all the changes. So I updated the server, I updated the token, and updated the certificate of my Kubernetes environment. Now I should be able to execute my thing. So I updated the keys. Now I should just apply my changes. So basically, I will call almost the same thing, but with the new file that I have, which is pipeline final. So what I'm doing here is basically telling the fly binary, the fly command line, to use to target the DevOps target that I created in the beginning, and set my pipeline called shopping cart. So if you see here in the shopping cart pipeline, this is the name of my pipeline. It's called shopping cart. So I'm asking it to configure it and use this file, which is the YAML file that I was changing, which has the content, this content. Yeah, so it has this content, all this content. And I'm telling it, get your variables from this keys.yaml that I was modifying here, where I added my private key, the certificate authority, the token, and everything that I'm referring to in this in the pipeline file. Any questions regarding that before going to the exciting part of deploying this? All right. Then all what we need is to hit enter, and we should be able to see. So this is asking me to validate if all the changes make sense to me, and this is what I'm expecting. Then yes, and this will apply the changes to my to my pipeline. So now you see this is kind of a closer view of a pipeline that that is really kind of it looks like very close to a production pipeline, even though a production pipeline can be so much more complicated because it will contain many inputs and outputs, and it will contain many stages. But this is really representative. Like it will always, you will have different kind of unit tests and probably I don't know, integration tests and different kind of approvals. And then different kind of builds. You can build different things at the same time, and then you will have different stages of deployment in different environments. But this covers like the biggest part of it. So it will take some time to build. So now, if you remember how we did the build before, it was a Docker build feature. So here you see that it logged into my Docker environment. Then now it is pushing the Docker changes. It did the Docker build, and it is pushing the Docker changes to Docker Hub. After that, after the build is done, and as we described in the pipeline, so we said that first thing, run the unit tests. So we see here that the unit tests were run, and if you succeed the unit tests, then do the build, and now it is doing the build, which is here. So it passed the unit tests, it did the build. After doing the build, if it passes the build phase, then we will execute the deploy part, and you can follow that happening in your in the environment. And let's also check that if we do kubectl get posts, we still don't have anything because we didn't do any deployment. So anything that will happen in the future should happen using this this pipeline. It might take some like few more minutes, for example. It depends on what kind of image you are deploying, what kind of checks are you doing, and what are the dependencies that you are getting, and so on and so forth. But this is how it should look like. So now it is running, and it is doing the different steps that we have. Yeah, you see that it is doing the, so if I do Docker build in my environment, it will be doing the exact same steps here. So it created that thing, it did the build, and now it is successfully tagging it, and it is using the tag that we specified, which is dev, and now it is pushing it to Docker Hub. All right, now it almost succeeded. So we will say, so this is the hash of that Docker image, and like it will take a few more seconds before okay. So now it succeeded. So when it succeeds, it becomes green. So after a few seconds, it will kick off the next stage, and so on and so forth. So if we have many stages, so it will do the same. So for your question, Ahmed, also, so you see like the shopping cart. So now it is getting the shopping cart. Then also it will download the image, the Docker image that defines the resource, which is the resource type that we defined here. So it will basically do a Docker pull on this image. So if we look here, it is doing a Docker pull. It did a Docker pull on that. This is the resource. If you can see it here, I don't know if it is clear to you. Yeah. So it is getting that resource from Docker. Then it is using the info that I specified here, and using the certificate and token that I did. And now, like it did the deployment, and then it needs to wait, because I told it wait until the shopping cart is ready. So now it did wait for it to be ready. Then once it is ready, it declared that the pipeline succeeded. Now our pipeline succeeded, and if I do kubectl get pod now, you will see that it is up and running. So like the intent of having all this set up and this platform. So now we have our pipeline ready. So now if I do any change, so let's imagine I go to my shopping cart, and I don't have any changes here. If I do, let's say, I will introduce some. Let's imagine I will introduce an error here. Let's say, I don't know, I will just write my name. Okay, so we know that this is an error, right? So it should not go to production. So if I do git add git commit minus error and git push, let's see what's gonna happen. So we said that the pipeline will protect me from having a bad configuration in my environment. So let's see if this pipeline will do that for me. Let's look at that. Okay, so it kicked off the pipeline, and we'll see what's going to happen here. So basically, it is cloning the GitHub, and then trying to put the right dependencies and run the unit tests. Oh, yeah, actually, it's gonna proceed here, but the next step should be yeah. So this one should do the build. So this one should fail. So it is basically doing git build of my main. All right. So this should detect this part. So let's see how it goes. In some scenarios, people can have a first a first stage before this one that will do only the build before even running the unit test, because this will check if there are any issues with the code. Okay, so now it will, so it got the code, it got the Golang image that is required for the build. Now it will start doing the build in a couple of seconds. Okay. Okay, so now it is copying all our content, and it will run the, okay, so it is downloading any dependencies, and now it is running the build itself. Let's see if it will detect that or it will not. So, okay, right. So it failed. Then we should not proceed, and it will show us that there is something bad. And if we look at the log, we will be able to define that there is something that is not right. And if we want to address that, so if I just remove this change and put some meaningful code, for example. Let's do a println. Okay. So now I can repeat the same thing. So now it will kind of proceed. So it will just redo everything and do the deployment, and everything should be corrected. So you can see now that I am not interacting with the pipeline anymore. I'm not doing any unit tests manually. I'm not doing the build manually, and I'm not doing the deploy manually. So I just run my code and ship it, and everything should be automatic. So this will reduce the test that I'm doing. It will reduce the time that I'm focusing on these tests, so I can focus more on my code because everything else will be done for me. Any questions related to that? All right. So yeah. So with that, I think this concludes this session. I will just wait a few seconds to see the pipeline succeeding. There is a small quiz in the end of the of this section in the platform. So if you wanna take that quiz, yeah. But other than that, I guess. This is all for the session, unless if you have any questions that I can answer related to this or to any other things. So let's see if this pipeline will succeed, and we still have 1 more minute. So I wish that it's gonna take a minute or less. Let's see.
Bonjour Mohamed. Pour les unités, est-ce que c'est nous en tant que DevOps que nous doit les définir, ou bien c'est le travail du développeur?
So it is kind of a philosophical question more than. So it is an organizational decision. So generally, like what is recommended is that whoever writes the code should write the tests. But there are some organizations that do not follow this this best practice, where you have some developers writing the code and you have testers that are trying to test the code. But generally, like who is the right person that understands how the code works is the developer. So generally, people like the developer should write the test. So if you write the code, you need to write the test for that code. And the test will help you understand how the code works and how it targets any edge scenarios. And if you are interested in these test story, also I have some content in the beginning of the course. Like if you go to the first part, I have a section on TDD. So here, yeah, I have a section on test-driven development, because people here start to do TDD more often, which means that you write the test before writing the code. So you start thinking how my code should behave, how should it respond to this scenario. Then you write the code that will answer this scenario. So this way, you will be writing only the needed code, and you will cover all the edge scenarios because you are writing the test for them. And this will protect you from future changes, because you already have some specification in the test that you will need to respect in order to introduce any new changes. So this is why it is always advised that the developer should write the test, or he should even start by writing the test before the code. All right, so okay, so now it is almost done with the push of the image, and it declared this as successful. So you can also see the different versions of your like the different instances or the different iterations that your pipeline went through. So we see here that it succeeded in the first iteration. It failed when we introduced an error. Now it recovered because we have a new version that is correct, that is passing all the requirements. Now we are doing a deployment, and we can do we can check that our deployment is gonna get updated. So yeah, so it is configuring the Kubernetes stuff, and we'll see. So now it declared this as a successful deployment. So we can say, so there are different ways that we can improve this pipeline. But this is like the minimum, the minimum like thing that covers most of the scenarios. So there are some people who decide, instead of only doing a new deployment, go and delete the previous pod and deploy the new one. And I will not do that right now. Because I guess that this covers most of the scenarios that you can do today with your applications. So if you have any questions, feel free to ask them now. So I will go ahead and stop the recording.